am going to discuss about Rast method. This method is employed to determine the molecular weight of the substance. This method is based on colligative property, depression in freezing point. That is, when a non-volatile solute is added to a solvent, the solute will lowers the freezing point of the solvent. From the known weights of solvent and solute and molecular mass, we can calculate the molar freezing depression constant Kf of the solvent, which is also known as cryoscopic constant. From this cryoscopic constant, we can determine the molecular mass of the unknown solute. Experimental setup for this method includes a boiling tube fitted with thermometer and stirrer, and also a water bath. First, we have to determine the freezing point of the pure solvent. A known amount of solvent is taken in a boiling tube and it is heated up to its melting point, and the melting point is noted, and the boiling tube is removed from the water bath and allowed to cool at the room temperature. On cooling, the freezing point is noted. This is the freezing point of pure solvent. Now, after the determination of freezing point of solvent, now solute is added to the solvent and it is fitted with the thermometer and a stirrer and heated up to its melting point. The melting point is noted and the boiling tube is removed from the water bath and allowed to cool on the room temperature. Now the freezing point is noted. Difference between the freezing point of pure solvent and the freezing point of solvent plus solute will give the delta T value. From this delta T value and the known amount of solvent, known amount of solute, we can calculate the Kf value. From the experiment, we get the result of melting point that for pure solvent, melting point is 70.4 and freezing point is 70.2. We get the average 70.3. After adding solute to the solvent, the melting point and the freezing point, there is a difference in the freezing point. The freezing point is lower when compared to the pure solvent. We will get an average of 68.5. Further addition of solute to that solvent, it still lowers the freezing point. That is about 66.6. From the two different temperature, that is depression in freezing point, we will get two Kf value. One is solvent 5 gram and solute 0.5 gram, 10:1 ratio. We will get the depression in freezing point and average difference between the solvent and solute of 1.8 degree Celsius. Applying 1.8 degree Celsius with W1 5 gram and W2 is 0.5 gram, we can calculate the Kf using the formula. Kf is equal to delta T into M into W1 divided by 1000 into W2. So delta T is 1.8, W1 is 5 gram, W2 is 0.5 gram, and 154.21 is the molecular mass of the solvent. Calculating these values, we will get the Kf 2.7757, and this is the unit of the Kf. Further addition of solute to the solvent still lowers the freezing point to 68.5 and an average of 66.6. The temperature difference between the solvent and solid solute is 3.7 degree Celsius. Applying the change in temperature and the value of solvent and solute gives the Kf value. So that we have obtained two different Kf value for two different solute added to the solvent. Repeating the experiment with solvent and unknown solute, we will get the melting point of solvent and the freezing point of solvent. From the average temperature, from the melting point and freezing point, we will get the average temperature of 17.7. After adding solute to the solvent, we will get the average temperature of 68.4. And further adding solute, we get the average temperature of 67.4. So from this solvent and first addition of solute, we get the temperature difference of 2.3, and after the second addition of solute to the solvent, we get 3.3 degree Celsius as the temperature difference. So taking the temperature difference and weight of the solvent and solute and Kf we have calculated already. The molecular weight is determined using the formula M is equal to 1000 into Kf into W2 divided by W1 into delta T. So the value of delta T is 2.3. Applying this value and we will get the molecular mass of unknown substance 120.68 gram per mole. Further addition of solute, we get the change in temperature 3.3. Weight of the solvent 5 gram, weight of the solute 0.8 gram, Kf 3.5561, and applying these values we will get another molecular weight 172.41. I want to summarize the Rast method. First, the freezing point of pure solvent is determined. After that, solute of known molecular mass at two different amounts are added to the solvent, and individual addition, the freezing point is determined. From the temperature difference between the freezing point of pure solvent and each addition of solute to the solvent is give us the molar freezing depression constant. From the first addition, it is determined that is 5 gram of solvent and 0.5 gram of solute. We have obtained the Kf value of 2.7757. After determination of this value, 0.3 gram of solute is added to that mixture. It gives another Kf value, that is Kf is equal to 3.5561. This is the unit of using these two Kf value, we can determine the molecular mass of the unknown substance. From these two Kf value, the molecular mass of the unknown substance is From the first kf value, we obtain 120.68 gram per ml. From the second kf value, from the first kf value, we got 120.68 gram per mole. From the second kf value, we obtained mu is equal to 172. Mu is equal to 172.41 gram per mole. So first, from the difference between the freezing point of solute and the solvent, molar freezing depression constant is determined. From the molar freezing depression constant, molecular mass of the unknown substance is determined. So if we have any queries regarding this experiment, you can post your queries or your doubts in the comment box. Thank you very much for watching.